Ever stop to think about how we actually know things? I mean, not just beliefs or opinions, but solid understanding.
Yeah, how do we get beyond just guessing?
Exactly. Today, we're plunging into the very heart of how knowledge is built, exploring, well, the scientific method.
And our guide is a pretty interesting online resource called E-Learning Scientific Method. It features this character, Brother Gregory.
Right, and it's been captured in snapshots over a long time, 2003 to 2023. It shows how these core ideas endure.
What's really neat is how Brother Gregory gets right to the core of systematic inquiry.
So our mission in this deep dive, for you listening, is to unpack those essential steps.
And show how even a simple question can become, well, a really powerful tool for understanding the world around us. We'll try and pull out some surprising examples.
Absolutely. And Brother Gregory starts with something wonderfully down to earth. His friend, Brother Matthew, thinks Brother Gregory's sore feet can predict rain.
Huh? Okay, that sounds specific.
It does, but right away, this introduces a fundamental concept, a hypothesis.
Ah, the hypothesis. So plain and simple, it's just a statement like, my feet can predict the weather. Kind of an initial hunch, right?
Exactly, a hunch, a proposed explanation. Now, what makes this scientific is that Brother Gregory doesn't just, accept it.
He questions it.
He asks the crucial question, is this statement true? Can my feet predict the weather?
And that immediately points to the next vital step.
Yeah. You need evidence. You need data you can actually look at.
So how does he go about getting this evidence? He talks about making qualitative observations.
Qualitative, meaning descriptive, not numbers yet.
Right. He keeps a record in his book, simply noting if it rained the day after his feet were sore. He's just looking for a pattern, a consistent link.
Seeing if there's a connection. And the idea of prediction is key here, isn't it?
Totally. For Brother Matthew's idea to have any scientific weight, it needs to accurately forecast what will happen.
So if rain always followed sore feet, well, that would be a striking result. It would suggest some kind of connection. Yeah, a dramatic outcome, definitely. Though, as Brother Gregory points out, it wouldn't automatically prove that sore feet cause rain.
Ah, the classic correlation isn't causation. Just because two things happen together doesn't mean one makes the other happen. That's such a crucial point.
It really is. It can save you from a lot of wrong assumptions, whether you're reading the news or even, in personal relationship.
Good point. So what if no pattern shows up? What if it rains sometimes, but not others, regardless of his feet?
Well, then the initial hypothesis, it just has to be set aside. It's not about being right from the get-go.
It's about following where the evidence actually leads you, even if it means ditching your cool idea.
Exactly. And this is where things get, well, a bit more realistic. Brother Gregory wisely notes that few things in nature are totally black and white, all or nothing.
Right. You might find that rain follows sore feet some of the time, maybe slightly more often than chance, but not always.
So then the scientific work becomes figuring out how strong that connection really is. Is it reliable or just, random coincidence?
Which leads directly to the first little investigation in the lesson, right? It prompts you, the listener, to think about it.
Yeah, it asks, have you ever noticed a link like that? Did it happen every time? Most of the time? Or was there, no serious connection at all? It's about getting you to engage.
I like that. Then Brother Gregory takes a smart turn. He considers other possibilities.
He does. He suggests that environmental factors, things like changes in air pressure, temperature, are probably more likely to affect the weather.
Which, intuitively makes more sense from a scientific perspective.
It does seem more reasonable, yeah. Though he admits it's also more complicated to test because there are just more factors involved.
So how do you test that idea?
Well, the process is similar to the sore feet one.
Okay.
It involves collecting more qualitative observations again.
Okay, but this time noting things like air pressure readings, temperature, and then seeing what the weather actually does.
Exactly. Looking for correlations between those environmental factors and whether it rains or not.
Got it. And that brings us to the second investigation in the lesson.
Right, which asks if you found any specific combinations of environmental conditions like low pressure and high humidity, maybe that seemed to predict the weather more reliably than the sore feet hypothesis.
And, crucially, did any set of conditions predict rain with 100% accuracy?
Which really highlights the goal, doesn't it? Finding more robust, more reliable ways to understand and predict what's going on.
Definitely. And the lesson even gives a hint for getting better results.
Oh yeah, the tip about repetition. It suggests trying each experiment or each set of conditions at least 20 times.
Which touches on a vital point in science. Sample size matters. The more data you gather, the more confidence you can have in your findings.
It's like that coin clip example, isn't it? Flip it twice, get heads both times, you might think it always lands heads.
Flip it 100 times, and you'll get a much, much better sense of the real 50-50 odds.
Yeah.
It smooths out the random fluctuations.
Makes sense. So at this point, Brother Gregory sort of zooms out a bit.
Yeah, he congratulates the learner on using the scientific method and stresses it's not just for weather forecasting.
He outlines those core steps again, often starting with a question or an observation.
Then forming a hypothesis to try and explain it.
Making a prediction based on that hypothesis.
And then rigorously testing that prediction. Seeing if it actually holds up against reality.
And this brings up that interesting kind of philosophical point about truth in science.
Right. Brother Gregory points out that if our predictions turn out to be correct more often than not, the hypothesis might contain a grain of truth.
But that truth itself is often complex, nuanced, not always a simple yes or no.
Very true. The lesson then shifts gears a bit, moving towards quantitative observations.
So now we're talking numbers, measurements.
Exactly. And the new example Brother Gregory uses is his observations of bees.
Bees. Okay, what's the hypothesis this time?
He hypothesizes that older bees travel further from the hive to find food to forage than younger bees do.
Okay. That sounds testable. How does he go about testing that?
He comes up with a pretty clever experiment, actually. He describes marking newly hatched bees with tiny dots of paint.
Ah, so he can identify individuals.
Yep. And he keeps track of when they emerged, so he knows their age. Then, throughout the summer, he observes which marked bees visit flowers at different distances from the hive.
Okay, so he's collecting data on bee age and foraging distance. That gives him hard numbers to work with.
Precisely. And this naturally leads to the third investigation in the lesson.
Which encourages you, the listener, to imagine doing this bee experiment yourself and then trying to make sense of the results you might collect.
That hands-on kind of thought process is really valuable, I think, for grasping how this inquiry works.
Definitely. So what's different here is the type of information. We've moved from did it rain
Yes.
to actual numbers.
Quantitative data. The number of bees observed, the exact distances they traveled in, say, meters, the precise age of the hive or the bees.
And this kind of data allows for much more precise analysis and comparison, right?
It does, but as Brother Gregory rightly points out, just having a big pile of numbers can be, well, overwhelming.
Yeah, I can imagine. Just looking at rows and columns of figures, it's probably hard to spot any underlying trends.
Exactly. It's difficult to see the forest for the trees, so to speak. And this is where visualizing data becomes incredibly helpful.
Ah, like making graphs.
You got it. The lesson introduces bar graphs as a way to take those raw numbers and present them visually.
Suddenly, patterns can jump out at you. Like, are the bars representing the older bees consistently taller, meaning they traveled further than the bars for the younger bees?
Right. And he also stresses the importance of then using words to actually describe what those visual patterns mean. The graph shows it, but you need to interpret it.
Makes sense. So once the data is collected and displayed clearly, maybe in a graph?
Then it can be directly used to test the original hypothesis. In this case, whether older bees really do forage further away.
This is the crucial step where you connect the information you've gathered back to your initial question. Did the evidence support your hunch or not?
And this naturally leads into thinking about chance and probability.
Probability.
So, what are the odds? Exactly. Brother Gregory even mentions, kind of surprisingly, that this field has its roots in studying games of chance, like dice and cards.
Gamblers helping science.
Well, understanding likelihood and odds is essential for interpreting scientific findings. Is the pattern you see real, or could it just have happened by chance?
Like the coin flips again, you expect roughly 50-50 heads tails over many flips. That's probability in action.
And he highlights that things like how much data you have, your sample size, and the range of possible outcomes. These are really important when you're thinking about probability.
They affect how reliable your conclusions are.
Absolutely. Also, how you collect your data, your sampling methods, and how that data looks on a graph, its distribution. That all matters for making fair comparisons.
Like comparing the distances flown by young bees versus old bees, you need to be sure you're comparing them fairly.
Right. And scientists use statistical tests. We don't need to get into the math. But these tests help determine if a difference, like the one between old and young bees' flight distances, is statistically significant.
Meaning it's unlikely to be just due to random chance.
Basically, yes. It helps us be more confident that the pattern we're seeing reflects a real effect.
Okay. So Brother Gregory wraps up his lesson with one last challenge for the learner.
He does. Use the bee data you've hypothetically collected and analyzed to figure out if there really is a significant difference between how far the bees travel and how old they are.
It's the ultimate test of that initial idea using the numerical evidence.
And finally, it's worth just briefly mentioning the required readings that go with this lesson.
Oh yeah, what do they cover?
They dig deeper into key ideas in probability and statistic sampling, bar graphs, descriptive statistics, hypothesis testing, chance, odds, sample size, outcomes, distribution, comparison, all the stuff we've touched on.
So the building blocks for data analysis.
Pretty much. And interestingly, there are also essays listed on curiosity and madness,
Curiosity and madness, that's an intriguing pairing.
maybe hinting at the intense passion and sometimes, the unconventional thinking that can drive scientific discovery.
Could be. And there's recommended reading, too.
Yeah, inviting you to learn more about Brother Gregory himself and something called Science at a Distance.
Interesting stuff. Okay, let's try and unpack this. What are the real takeaways here for you, the listener?
Well, I think the main thing is seeing how the scientific method provides this structured way to ask questions and seek answers.
Right. Moving logically from simple observations, maybe a hunch, a hypothesis, through the process of actually gathering information.
Whether that's qualitative, just describing what you see, or quantitative, taking measurements.
And ultimately looking for patterns in that information and testing if your initial idea holds water.
Exactly. And for you, the learner, understanding these fundamental principles is just incredibly valuable. It equips you to look at new information, you encounter articles, news reports, whatever, with a more critical eye.
And maybe approach new topics you want to learn about with a kind of structured curiosity.
Absolutely. As Brother Gregory's examples show, even really simple, everyday observations can be the starting point for genuinely profound insights into how the world works.
Think about maybe a nagging problem you've been grappling with. At work or home, you've probably got a few hypotheses about why it's happening, right?
Yeah, we all do that intuitively. The scientific method just gives you a more formal, structured way to test those hunches systematically, instead of just guessing or assuming.
And here's a final thought to maybe mull over. How could these steps, observing, forming a hypothesis, making a prediction, testing it, apply to a question, or even a problem you're currently wrestling with?
Could you use this kind of framework to gain some new understanding? What kind of data, quote unquote, might you need to collect, even if it's just observations?
It's a powerful way to think.
For sure. And, this deep dive has really just scratched the surface. Those related ideas, probability, how to interpret different kinds of data, even the historical context hinted at in the readings, offer fascinating avenues to explore further.
And understanding this process can also make you a much more discerning consumer of information in daily life, can't it?
Oh, definitely. Helping you spot flawed arguments or claims made without real evidence in things you read or hear.
So what does this all mean? Hopefully this exploration of Brother Gregory's lesson has given you a valuable framework.
Yeah, maybe a new lens for looking at information, and hopefully it encourages your own journey of discovery, asking questions, and seeking evidence-based answers.